Thus, equation 2 becomes IT is equal to I0E minus K dash C. I is equal to I0 10 raised to minus 0.434 K dash C. KT is equal to becomes I0 10 raised to minus K dash C. So where small k dash and capital K dash are constant and C is concentration of the absorbing substance. On becoming combining equation 3 and 4, 3 and 5, it becomes IT is equal to I0 10 raised to minus ACT and log I0 upon IT is equal to ACT. Then equation 6 is termed as a mathematical statement of Beer-Lambert's law, and this is a fundamental equation of the colorimetry and spectrometry. In equation 6, the value of dependent upon unit of concentration if C is expressed in mole dm raised to 3 and it T is a centimeter, the A is replaced by the symbol epsilon and termed as a molecular absorptivity of a molecular absorption. So AE nothing but a particular expression in a symbol. So relation between the absorbance transmitter and molarities absorptivities become A is equal to ECT is equal to log I0 upon IT is equal to log 1 upon T is equal to minus log T. So epsilon become A, capital A by CT. So these are the derivations of this equation. So the derivatives or these derivations are already derived properly with respect to Beer's and Lambert's law. Then a reason for the deviation from a Beer's-Lambert's law. So what will be deviation? Deviation nothing but due to some of the things law is not followed properly. So what they are? First is a true deviation. So what is true deviation? True deviation are related to the concentration of absorbing substance. So Beer's law holds good only for dilute solution. So if concentration is matter for the follow the specific Beer's and Lambert's law. So dilute solution only follows the Beer's law. So it is a true deviation for this Beer's deviation from the Beer's-Lambert's law. Because Beer's law is related with the concentration and your Lambert's law is related with the thickness of particular material which is in our cell or solvent which is in our sample cell. Then chemical deviation. Chemical deviation arises if the absorbing specific species undergo the chemical changes. Such a association with complex formation, dissociation, hydrogen bonding, hydrolysis, ionization or polymerization. So means what will be happen due to some chemical reaction, chemical changes their property, and due to that they doesn't follow the particular Beer's and Lambert's law in this case. Then next is the instrumental deviation. It is also called as technical deviation. That is only the monochromatic light gives the Beer's law. Use of polychromatic light gives negative deviation. So monochromatic light and polychromatic light matters follow the Beer's law. So any function in intensity of light, changes in the sensitivity of detector and improper slits width can lead to the deviation of the Beer's law. So it is the technical deviation due to that if it is not have the proper instrumental property to that instrument, that does not follow or they do not follow the Beer's and Lambert's law in this case. Then some important terms related with this UV spectrophotometry. First is the chromophore. So what is chromophore? Already we see some of the important thing is the compound which having the pi to pi transition and all. So the energy of radiation begins absorb being absorbed during the excitation of the electron from the ground state to excited state preliminary depend on the nuclei that hold the electron together in a bond. So chemical structure is very important for the absorption of the radiation energy. So the group of atom containing electron responsible for the absorbing the chromophore, it is called as chromophore. So most of the simple conjugated chromophore gives rise to the high energy transition of the little use in this case. Then what is auxochrome? So the substance that themselves do not absorb the ultraviolet region, but their presence shift the absorption maximum to the longer wavelength called as auxochrome. So chromophore absorb the ultraviolet radiation. Auxochrome does not absorb, but they deviate or the shifts the absorption maximum to the longer wavelength. It is called as auxomer. So the substance like methyl, hydroxyl, alkoxyl, halogen, amino group, etc. are some of the auxochrome. They shifts the absorption maximum to the longer wavelength and called as auxomers. Then absorption and intensity shift. So bathochromic shift, hypsochromic shift, then hypochromic shift and effect, and hypsochromic effect and hyperchromic effect. So this is the diagram that will give the idea about the shifting intensity. So this is the graph of wavelength versus molecular absorption coefficient. This is a hypsochromic shift, is hyperchromic shift, hypochromic and bathochromic shift. So this is what? So first is the bathochromic shift. It is also called as red shift. Name itself indicate that red shift means towards the red region of the electromagnetic to get shifted the wavelength. So a shift of the absorption shift towards the red, maximum towards the longer wavelength or lower energy. Towards let is considered the spectrum. Then hypsochromic shift is, or it is called as blue shift. It is the shift of a absorption maximum toward the shorter wavelength or high energy. So these are the extreme energy for it is up to the red or up to the blue region of the spectrum. So bathochromic is for the longer wavelength and it is the shorter wavelength hypsochromic shift. So it becomes the bathochromic towards red and hypsochromic towards the blue, maximum and higher and lower. Then remaining is the hypsochromic effect, an effect that results in a decrease in absorption intensity. Here is the hypsochromic intensity is decreases and hyper is the intensity is the effect of resulting increase the absorption intensity. So this is the graphical presentation give us the idea about hypsochromic, bathochromic, hypochromic and hyperchromic effect respectively. Then effect of solvent, a very important thing is during any type of the analysis in case of the UV radiation, it is know about what are the solvent effect is there. So high pure or non-pure solvents such as the saturated hydrocarbon do not interact with the solute molecule either in a ground state or excited state, and absorption spectrum of the compound in the cell is similar to one of the pure gaseous state in this case. So however, a polar solvent such as a water, alcohol, etc. may stabilize or destabilize the molecular orbital of the molecule either in a ground state or in excited state, and spectrum of the compound in the solvent may significantly vary on a record date in a hydrocarbon solvent. So solvent effect takes place in that case. Then next is the important point is the instrumentation. So it is a light source, that is obviously it is the UV light source. Then it is a collimator, it is lens. Then monochromator, which is give the specific type of the monochromatic light. So it is a monochromator and which absorb incident white light and gives the n number of the colored light or monochromatic light. We pass the only one monochromatic light by the slit, that is slit, wavelength slitter selector, which give the proper wavelength selecting and absorbed by this matter or object, and light become incident light I0 and transmitted light IT. Sample solution is a cuvette. And next is a detector. It is exit slit. It is of exit slit, entrance slit, and it is digital display or meter. Then what are the components of instrumentation? First is the source, a stable source of radiation energy at the desired wavelength used by this source, that is particular range. Then wavelength selector, a device that isolate or restrict the region of the electromagnetic spectrum used for the measurement, that is monochromator and prism and filter. So specific wavelength we select for the analysis of the specific type of the component in this way. We will see what in detail what is a monochromator, what are the prisms and filters. Then sample container, a transparent container used for the hold the sample, that is cuvette, and it may be sample cell. Then detectors or photoelectrical transducer. Then these are the converts the radiant energy into the usable signals, usually electrical signals. Then last is signal processor or readout system. In that case, amplifies the or attenuate or increase the transducer signal or amplify the signals and send to the readout device at a meter or a digital readout system or particular chart recorder or computer, etc. in this way. Then what are the sources of a light? So tungsten, halogen lamp, hydrogen or deuterium lamp, xenon discharge lamp and mercury lamp we use as a source as a UV radiation. Then what is the first tungsten halogen lamp? So that covers the wavelength ranging from the red end of the visible to the near the ultraviolet range, that is 750 to 800 nanometer to 320 nanometer, this range. So the lamp is provided with a coarse outer sheet to permit the use of the ultraviolet part of the emission. So this is the tungsten halogen lamp that produces the source of UV radiation in this case. Then hydrogen and deuterium lamp. It is mainly used for the measurement of the ultraviolet region down to the 200 nanometer, and it consists of the two electrode dipped into the deuterium filled silica envelope. So it is deuterium filled silica envelope in this diagram, and this cathode deuterium anode is there, and which produces the ultraviolet radiation. Then xenon arc lamp. So intense radiation bypass of the current through an atmosphere of xenon, and spectrum is continuous over the ranging between 250 to 600 nanometer, peak intensity about 470 nanometer. So which produces the UV visible radiation in this system, xenon arc lamp. Then mercury arc lamp. It produces the intense line spectrum about 350, but higher pressure lamp gives line at 366, 440. So these are the mercury arc most of gives the colorimetric radiation. So lower pressure lamps use additional radiation at 254. So this is the range only occupied by the near to the visible region. So combining, we use this in a UV visible radiation or UV visible analysis. Then filters and monochromator. So first of all, know about what are the filters. Primary filters absorb the visible radiation and transmit the UV radiation. Secondary filter absorb the UV radiation and transfer the visible. So depending upon what type of analysis you want to do, we use the primary and secondary filter and passes on your object or material and do the analysis. Then monochromator, excitation monochromator, only the radiation which is absorbed by the molecule, and excitation monochromator, only the radiation emitted by the molecule. So excitation and emission, two types of monochromator are there. So wavelength selector that can continuously scan the broad range of the wavelength and used in the most scanning spectrophotometer, including UV visible and IR radiation. So there are types of filters. So absorption filter, work by the selective absorption by the unwanted wavelength, and it consists of the solid sheet of the glass colored by the pigment which is dissolved in a dispersed into the glass, and dye, gelatin or similar material used in absorption filter, and they are perform a cutoff filter and a band pass filter.